Hi everyone, my name is Chiming from International Department. We're going to wait a few minutes for everyone to join in, and I will take the occasion to mention that we're going to do a raffle on GoToWebinar. So please, if you're watching this on LinkedIn Live, you can go to the webinar description or the chat to get your information into the GoToWebinar registration so that you can get a free license. Welcome to today's webinar, From Foundations to BIM. An in-depth look at CYPE's composite structures. Joining us today is Sonsoles, civil engineering from our technical support. Hi Sonsoles, how you doing?
Hi everyone. Hi Timin. How are you doing?
Very good. Thanks for joining us today. So in the
Thank you.
meanwhile, I'm gonna mention a few things first. We'll turn off the camera first so that you can focus better on the screen, okay?
Okay.
Okay. As you can see, this is a platform named BIMserver.center. Could you please show us the BIMserver.center, please? Thank you. It's a program that actually a CDE platform that hosts our software. So with this platform, you can do more than just download. Also, we can manage projects. And Sosoles, could you please give us a quick look on it?
Sure. Okay. So as Timin just said, BIMserver.center, okay, is free to register. So feel free to do it. Registration, when you Google BIMserver.center, you will come up with this and you can register totally for free. So BIMserver.center is a platform designed to create and manage BIM projects, okay, not only yours, but you can interact with other professionals too. And you can interact with other professionals and, of course, find the best open BIM tools in the market. So yeah, that's BIMserver.center.
Okay, thanks, Sonsoles.
All right, so let's get into today's matter, which is composite structures. Okay,
Sorry, sorry, I have to interrupt you.
that's fine.
And before the webinar begins, I want to address that if you can't watch us smoothly or have any questions during the presentation, please feel free to use the chat to communicate with us, because we want to ensure that everyone has an enjoyable experience during the webinar. So during today's webinar, Sonsoles will show us the key features of CYPECAD and CYPE3D for the complete solutions of composite structures. Now, without further ado, let her walk us through the features and capabilities of CYPECAD and CYPE3D.
Okay, so besides BIMserver.center, I wanted to point out that we also have our website, info.cype.com, where you will be able to find our professional solutions for structures, for example, which is what we're going to see today. So today we're going to go over CYPECAD, CYPE3D, and I will show you in the end probably an example at CYPE Connect, okay? And let's start with in CYPECAD, okay? Let's start from the elements columns, okay? So here you can see we're at CYPECAD. I will go back and forward from CYPECAD to CYPE3D. I will point out whenever we move into the other software. But here at CYPECAD, you can see that I have already inserted some columns. And we're going to start taking a look at reinforced concrete columns. So this can be either a rectangular shape, a circular shape, or you could create with this tool any kind of other section.
You just said like creating other sections. You mean like whatever sections we
Yeah,
want?
yes, whatever section. So if you click here on generic sections and create a new one right here, you could insert any geometry. Just if you know the geometry, you could insert there right by points. Like you could use the different tools there are to insert the geometry. for example, this one. Whenever it's done and you click on the right button of your mouse, it will automatically generate the mechanical characteristics of the section that you create. But you can not only insert it by points, you can also, and this is common to both CyPECAD and CYPE3D, and not only for this generic section, but you can always upload a template if you have it. So for example, I have here a geometry that I have created with a drawing software. And if I activate the templates object snap here, it will help me insert any geometry. So that's my template, and actually I can start inserting this section just by just this easy, like 2 clicks, and you snap the template and it can be generated as easy as this. So not only opaque sections, but you can also create openings. So here I'm going to create the square opening here in the middle. And as easy as this, you can create this and any other kind of sections. So let me skip for now the steel columns because we're going to see them better as CyPECAD, CyPE3D, sorry. So they're also here, like you can also choose any steel section that you will see also in CyPE3D. But let me move into timber columns first, and I will go to CyPE3D in a moment. So for timber sections, we have round bars, square bars, and rectangular bars. And all these sections, they usually come with an import predefined, like a tool to import predefined section series. So we have multiple series for most of the sections that you could import into your job and use them. Whenever you have the geometry, you can also choose the material of the element, and according to the code that you are analyzing the job with, you will have to also select other parameters. So let's take a look, a 3D look over the ones that I have just talked about. Let's so here you see the reinforced concrete rectangular column. The circular one, this one is the first generic section that I showed you how to create. This one is the other one that we shown. And of course, the timber column, it's right here also. So now I'm going to switch to CYPE3D to show you the steel columns, okay? And I would like to point out that here in CyPECAD previously, you could see that the work environment is 2D. One of the main difference between the two softwares is that CYPE3D can also be worked, like the work environment can also be 3D. You could choose between 3D views or 3D and 2D views also. So for depending on which structure you're working on, it might be easier to work on a 3D environment. Although CyPECAD can the work environment is only 2D, it has walls and slabs that can only be analyzed here at CyPECAD. So going to CyPE3D, let's take a look at all these other columns that I have here. So let's describe them. Okay, So I have chosen as this section to better see how like we not only can choose simple sections as a Z, but you could also select all of these other tools that will help you double the section and create it with double welded in box with continuous and discontinuous weld. You could also choose to create the um, the section with double inbox with cover plates, giving it you could give it a different initial and final spacing. Also, the weld can be discontinuous or continued, and double inbox with batten plates. And I believe this is better going to be shown if I show you the 3D view. So let's take a look at it. So even though this one looks like a square shape or a rectangular section, it's not, okay? I don't know if you can see the discontinuous line right there, but it's actually two C sections composed and in box, okay, with weld, a continuous weld. This other one was the second one, the second option that we were talking about. It's again the two C's, okay, although it looks like a rectangular that I could have inserted like a rectangular section, it's actually two C's that have a plate welded, and that's why it looks like a rectangle. So this was the one, the button plates. So again, the two C's pointing to each other in box, and the button plates. And this other one is an example that of the different initial and final spacing. Okay, so
So, sorry for the interruption. So apart from this, what other section do we have? Do we have more sections?
yes, we do. Give me just a second, and I'll show
Okay.
you the last ones with the C, and we'll move into another section. So
Okay.
there are another three options that I wanted to show you first, which are the double welded in I. Instead of the two C's pointing to each other in box, we can select the double welded in I, or again with plates and again with different spatial, like initial spacing and final spacing. Um, so of course we do have other sections which we have different materials to start with. So we have rolled steel, we have built up sections with rolled steel plates, we have comfort steel sections, timber sections, aluminum, excluded aluminum, concrete bars, and to describe in a generic section with any other material. If you know the parameters that define the material, the mechanic characteristics of the shape and the material, you can actually choose other ones. So I showed you the Z, but I have also inserted and I'll show you in a minute a column with this other symmetrical angle section, and another one with to show you that we also have the ability to import predefined section series here. In most of the sections we do have that, but if you find one that doesn't have the a library that you can import, then you can always click on new and create that section that you have selected given the parameters a value. So let's take a look at all of those. So this is what I was talking about. Like this is not a nice section, just a nice section. It's actually those same two C's but pointing outwards. Again, with the pattern plates, but can you see the double C's are in I shape. This is again I shape at different spacing. And this is the other thing that I was telling you about, that of course we have other sections. These are symmetrical angle sections, and this is the other shape that I was telling you about, but I actually doubled it to show that you can also double those. So let's take a look at the results. So when you analyze the job, and I have it already analyzed, um, you can start, for example, with checking the elements. So the software will show in green the elements that actually verify, and in red the elements that actually don't verify for some reason. Okay. So, for example, if I click on this one, this will show you rapidly what is the next possible section that will verify with the forces that you have in that that have been analyzed there. So you could choose a section that actually verifies, and to show you that this one goes like its resistance doesn't verify, I'm going to show you the deformed shape, and show you another tool this way. So I'm going to select the correct load case that actually gives this problem to the elements. So you can here see that the ones with the C that we created earlier are fine. Like the colors seem that the shape doesn't deform that much. But let's take a look at the animation. Like we can display this animation and actually see how those other two that I inserted, the last ones, and we could amplify this to better see the results. You can play this and see the deformed shape of the elements. Okay, so besides the checking the elements on screen and seeing them in green and red, you also have ULS checks. You could generate all these checks and like see the justification of the checks and why they don't meet. You can actually tell the software to only show the ones that failed, the failed checks. And whenever you have it ready, you can generate this report. It will show you like this section and all the checks.
In what kind of formats can we export this report? Only PDF?
No, not just PDF. You can export this and other reports that these softwares can generate. They can be exported into pretty much any kind of format. So here we see
Great.
that we can export it to PDF,
Mhm.
docs, text format, HTML, RTF. So not only PDF, you can export them into all these formats.
That's great.
Yeah, it's fantastic. And
And could you
I'm
please
not
show us, I'm sorry, could you please show us how to consult the reactions?
sure. So besides the text that I was telling you about, you can see here in the Analyze menu
Mhm.
that you also could also consult the reactions. So if I select the correct load case, you can see the reactions right here. And not only the reactions, but you can also create the force diagrams over the bars. So for example, let's check the moment and transitional moment of this one, for example. So again, you can amplify to better see the results. You can always play with the scales, and you could have the force diagrams and the values can be consulted too. So if we've placed the mouse over the bar, you can for the forces that you select, you can see the values over the different points of the bars. So speaking about reactions, reactions are important and then generate the foundation. So let me please first show you that we create base plates. So you can ask the software to design the base plate, and if the forces are normal and it can come up with a solution, it will. And it will then let you check the code checks, the complete report of the node, and the detailing.
I'm sorry. Speaking of codes, what kind of codes can CYPECAD and CYPE3D analyze the structures?
The structures can be analyzed in all this, let me show you, in all these codes. So
Okay.
we have all these codes for concrete, of course, European codes, American codes, British codes, South American codes, not only for concrete, but you can also see that you could pick between any of these codes for conform steel, steel, roll, foam steel, timber. We have codes from all over the world,
Mm-hmm.
and both here in Cype3D and CyPECAD. So that's common for both of them. Let me show you. Just want to point out that the report for the code check of the base plate can also be exported, as we said before, into all these formats. Okay, so multiple reports that you can generate, and here, for example, the base plate, you could also get a detailing of the base plate. So, speaking of base plates, let's move into these slab foundations here at CYPE3D still. And I'm going to show you on the kind of foundations that you can create here in CYPE3D. So that will be reinforced concrete footings, mass concrete footings, pile caps, tie beams, stripe beams, and beam with automatic balancing in the ends. So for footings, we can see, and this is common both for reinforced concrete and mass concrete. You have a square footing, rectangular footing, and eccentric footing. So the column doesn't have to be placed in the center, so it can be eccentric too. You can have tapered square footings and rectangular and eccentric as well. And the footing doesn't necessarily have to be of only one singular start, but it could have multiple starts. So that's common for the mass concrete footings too. And here are the pile caps. You also have the possibility not to only just one pile, but multiple piles, and of course not single start, but also multiple starts. So let's generate one so I can show you this feature. So here, if I edit this footing, I can show you that if you click here on design and complete, the software will come up with if it can, it will come up with a footing, like the dimensions of them, the reinforcement, but you can also choose the geometry of it and make it only generate the reinforcement for that, like try to come up with a reinforcement for the dimensions that you said, or vice versa. Like you could choose the reinforcement and see if it meets all the checks. Again, this report of the footing can be created and exported into multiple formats. So that's for foundations here at Cype3D.
Okay, I see. I see that you can insert about like any kind of footing, right?
Yeah.
But like, what about map foundation?
Great question. So mud foundations cannot be created here at Site3D, but that's because you can always take your 3D, like your CYPE 3D structure into CYPECAD, and CYPECAD does have matte foundation. So let me show you an example of that.
Okay,
Here we
good.
have a CYPE 3D structure. Let me
Mhm.
show you the 3D view of it. I have inserted a dome, okay, created here at Sci3D, and I'm about to take it to CyCAD, and then we could want that, for example, to generate the matte foundation. So let's do it. I'm going to go back to CyCAD now, and here in this job that you see is just CyCAD for now. I'm going to actually insert that dome. First, I have to make sure that I close it inside 3D. So I'm going to shut it. And now here you can see on CypCAD, sorry, you have 3D structure, integrated 3D structures menu. And in this menu, you have this option to import job from Sci3D. So that's what we're going to do right now. I'm going to choose the structure and place it over my structure here in CypCAD. So as you can see, like the Cype 3D structure is now placed over my CypCAD job. And not only that, but if I wanted to correct anything about that 3D structure, it's not just placed, but you have the opportunity to edit it. So the integrated structure menu here on CypCAD, because this icon is for CypCAD, opens a window that is just like the one at Cype3D. So you could operate in the 3D environment with this integrated structure and change anything you may need to change. So once we have our Cype3D job in CypCAD, or if you wanted to create a matte foundation for your CypCAD, and that's also true. I'm going to create one matte foundation to show you. I'm going to choose this, but we also have foundation beams to create the perimeter of the matte foundation. And now that I have a perimeter, if I click here on slabs, you can see that we have matte foundations right here. So let's insert it. And just like that, you can see that you can actually analyze matte foundations too, because you can always take your Site 3D to CyPECAD, and in CyPECAD you can create matte foundations. So let's take a look at these foundations, because I showed you very quickly in Site 3D the different options that we have for foundations, but here I think in the 3D view you can better see them. So of course we have rectangular and centered footings, but we can have it them eccentric too. This is an example of that pile cap with one pile. And this is the tapered footing, okay, that we talked about earlier. And this is an example that the footings don't need to be for a singular start only, but you can have them for multiple starts. And that's also true here with this pile cap. For multiple columns and different five piles in this case. So those were the foundation, like any kind of foundation.
Okay. So I know there like we have like different kinds of beams and slabs. So could you please like walk us through the different beam and slabs that are available and how they can form composite structures?
Okay, sure. So the composite structures come with mixing all these elements. So let's start with beams. Um, So here you can see that for beams, we have, of course, reinforced concrete beams and foundation beams. We have also non-structural, like they won't be analyzed. They're only to generate parameters and complete the job. And we have steel beams too, like we have, you could select it again from multiple sections, and we have timber sections too, like timber beams. So for concrete, we have of course flat beams, drop beams, lattice beams. You could pre-stress beams, and I think let me show you the slabs too, and then I will take a look at a 3D view over this, and you can better see them. So if I here you can see an example of I have inserted a flat slab, a waffle slab, and a joist floor slab, a concrete joist floor slab, which are right here. Like we have flat slabs, waffle slabs, of course with libraries too, joist floor slabs, and not only reinforced joist pre-stressed joist, but also we have steel joist and open wet joist and timber, of course. And another thing that I have inserted here is actually a composite slab by itself, like it's composite. And speaking of this, I will show you two thing that I forgot to show you, which are the columns, the composite columns too. So this slab is actually composite by itself, like it has steel and concrete both at the same time. And when I'm telling you about the concrete the composite columns, is that I forgot to tell you that here at columns we also have we talked about the reinforced concrete and steel and timber, but we have composite sections too for columns. So it could be like steel in the mid, in the inside, concrete on the outside, or it could be concrete in the inside and on the outside steel, with of course rectangular sections, square sections, circular sections, just like these ones. So here we have steel in the inside and concrete on the outside. We have steel, concrete, steel, so multiple forms of composite elements. Let's take a look at the 3D view over the beams and the floor slabs. So here I have inserted timber beams with joist floor slabs that are also timber. Here, moving into the next one was the composite slab that I was telling you about. This is a metal, like steel beam with concrete columns, and that composite slab. Here's an example of a steel beam with concrete columns, and that other slab it was steel joist floor slab. So you could create composite structures using all these elements.
Okay, one question.
Excuse me.
Uh,
Yes.
I'm interested in the stairs. Do you have stairs?
Yes. Yes, we do have stairs. So let me activate a template for the stairs. And here is the like right beside the 3D structures menu, we have the stairs menu. Here you can create a new staircase. You will have this system with these two tabs where you could actually come up with any geometry for your stairs. I'm going to insert this one. I'm going to choose the right object snap, and I'll show you in a minute what it looks like. Okay, so you can now see the stairs. And actually, let me delete this matte foundation just a minute to show you the 3D view of those other columns that we talked about, the composite columns. So here you can see that here we have those composite columns. I think it's interesting to take a look at them too. Okay, so you could use this stair menu, but let me show you an example of what a composite stair. So let's see in this job, which is a concrete building, I have inserted a stair that is actually composite because it's steel and timber stair. So they can not only be concrete, but you could also come up with a structure, a 3D structure, and insert it in your CyPECAD job. I would like to show you now, like I'm going to go over all these different interesting structures that I want to mention. So here we have another composite structure. The concrete part has been inserted here in CyPECAD directly, and then this is a 3D a 3D structure. So I showed you a little bit about reports, but I want to point out that both CyPECAD and CYPE3D have multiple reports that you can generate. Like you could generate the job data report. We have joins. We have all these reports. Some of them are not visible for this because, for example, I haven't analyzed this job with fire resistance, but if you had it analyzed with fire resistance, you will have the possibility to generate a report. And let's take a look, for example, your radios, and you could generate a report like this one, just like that, to see all the radios in your job, as well as, for example, the ULS checks. Excuse me. So for another example of the reports is this one, where it will tell you like list of the columns and every other element that is on your job, columns and beams. This is for columns and beams. If they verified or if they don't, the checks that verified, the worst case forces, and this, of course, as always, can be exported into any format. Not only reports, but we also have very good tools to generate drawings, automatic drawings. So you could customize them also. Like we have all these types of drawings, from floor plans to the 3D structure, drawings, columns, schedule, and you from this you could also configure multiple, like the outlines of the everything that can be configured. You could also configure them. So let's take a look, for example, at the drawings from this job. Like all these drawings are generated automatically. You just need to pick the type of drawing and customize if you want the lines to be wider or thicker, sorry. So let's take a look, for example, at this floor plan drawing. of this structure, and then again, as we saw, we could generate a drawing for the integrated structure as well. So that would be for an example of that. And it comes with the detailing of the base plates, and also if there are any joints in the job, you could also generate automatically the detailing for those joints too. So very interesting tools. And let's move into another interesting structure. For example, this one is also an example of composite structure. Here you can see like the bottom of this structure is concrete, and the roof is actually a steel structure, a very complex structure that can be analyzed here. Then wanted to show you this other one is a building, a concrete building with a little steel structure on top. So here we have it, another composite structure. It doesn't need to be only a metal, like it could be, for example, this other one is building, concrete building with a timber rooftop. Uh, So another example of composite, and of course the one that we showed in the beginning. They like the composite structures with the elements that we've been showing in this section can come up with structures as complex as this one. So it's just a matter of how many of them you composite, and those are the tools that I wanted to show you today of composite structures. I don't know if there's anything else we wanted to show, Jimin.
I do like at the beginning, we showed like BIMserver.center, right? So like
Yes.
I do want you to show us an example of the OpenBIM workflow.
Oh, sure. Okay. So let's see. For example, this 3D structure that has been analyzed. That's why it's in green. Like it wouldn't be like the check elements wouldn't work if it is not analyzed. So here I have it. I have previously created a project at BIMserver.center. Let me show you. Here Here are my projects. I have created a composite structure project at BIMserver.center, and I am now going to link this 3D job um, to that project. So I'm going to click here on link. I'm going to select the project. You don't need to have it already created. You could create it in this tab too. So I'm going to select the project and click accept. And now you can see here that I am logged into my BIMserver server account. The job is actually linked to the project there at BIMserver.center. And now if I click here on share, I have the opportunity to export the forces to design the connections, which is done inside inside Connect. So I'm going to click accept. And whenever this tells us that the export is finished, and I will come up with a percentage of what of that exportation is complete, and I'll show you in a minute.
Mm-hmm.
Whenever that's done, I will go back to BIMserver.center and show you there how we have actually like we have a contribution where there was an empty project. Now the information has traveled. So here, now that the loading is complete, let's go back to our composite structures, and you can see that we have a new contribution. So you could see that I have made a contribution less than 5 minutes ago, and that's the one that is right here. So you can see that the structure has traveled into BIMserver.center, and not only the structure, but the forces, like um, export, we said export the forces. Yeah, the forces have also traveled. So I can now open a new job here at CYPECAD. I'm going to leave it like that. Let's call it new. I want to link myself to the same BIMserver.center project where I have uploaded that structure. And now you can see that we have the ability to import that structure into CyPECAD. So I'm going to do it right now. And that's an example of the OpenBIM workflow, like from one app to the other through BIMserver.center. And now that we're here at SiteConnect, and this structure is steel columns and timber top, I will show you how we can also analyze composite joints. So let's, for example, create this joint. I have already worked on the joint, so let me import it from the library. I'm going to, this library is self-created, like whenever you work on the joints, you will have them available for other jobs. So I'm going to import this one and use it for this job. So if I have previously worked on the operations to create the joint, I'm going to, of course, use it. And let's create another one too. So what if let's create a new node here with these elements, and also let's do that one. So for this one, I want to use this joint, and I'm going to move into the analysis tab to show you that the forces on the elements has traveled from the 3D job. So I want to click here on loads just to show you that these are not empty, and I have created the the job, this CyPECAD job, completely blank, and importing the 3D structure. So the forces have traveled with the elements, and now we could analyze this joint and see how, like, the software can actually analyze joints that are composite too. We have bump stress that we could take a look at. And so that's an example of the OpenBIM workflow. Have gone from Site 3D forces and into CyPECAD to create different joints.
Okay, perfect. Do you have any more to share with
I don't think so. I think we're pretty much
for
I have
today, right?
covered everything that we want to talk about. I don't know
Yeah.
if you all have any questions, please submit them in the chat, and we'll answer them, take a look at them.
Okay, so thank you so much for sharing your expertise and providing us with this comprehensive overview of all. So in conclusion, okay, I'll turn on my
Yeah,
camera
me too.
first. Can you see me? Okay.
Yes.
Okay,
I
so
think
in
so.
conclusion, what we talk about today is CYPECAD and CYPE3D, and they have been developed to carry out the analysis and design of reinforced concrete, steel, timber, and aluminum structure, right?
No.
So, enabling a comprehensive methodology with unlimited potential, the program guarantees maximum reliability of analysis results and interoperability with different programs. And at this end of the event, we have an offer to whom attending today a limited time discount on CYPECAD, CYPE3D, and CYPEConnect. Could you show us the BIM server that page?
Sure.
So anybody that wants to purchase, don't miss out on this opportunity to enhance your engineering and design capabilities with CypCAD and CyP3D. You can access us by LinkedIn through our website. Later we'll send this link. I think I will send this link on the chat, right?
Hmm.
So you can get all three the softwares on our BIMserver.center, and you can get like a 10 days free trial, I think. So anyway again, we want to thank you everyone for joining us today, and we hope that you found the presentation to be helpful and insightful, and that you learned something new about these useful solutions. We look forward to seeing you at our near futures. So
Thank
bye.
you. See you next time.
See ya.